I am actually here to introduce Pete Lumbis. He's going to come up and talk to you guys. You probably know Pete from Cisco Live, helping people get in their CCDEs. He's formerly, I think he still might even be involved with some of the speaking engagements, worldwide. So I want to bring up Pete, and then we're going to talk briefly, and he's going to mention creating the self-aware network device. Thank you so much.
All right. So this is my very marketing titled, fluffy, creating a self-aware network device, or as I like to call it, Skynet Alpha Edition. So who am I? CCIE routing and switching, CCDE. I used to work in TAC for Cisco, supporting routing protocols, MPLS, multicast, BGP, on everything that wasn't an XR platform for a global customer base. I now work at Cumulus Networks. I help customers build, run, design very large data center networks. I do a lot of other stuff. What I'm trying to get across is not just that you should listen to me, but I am a network person, right? I'm a CLI jockey. I am not a programmer, right? I went to college for computer science, spent a long time writing really bad programs, and then went into networking for a very good reason. Because I am terrible at programming and nobody should pay me to do it. So I have no idea what I'm doing when I'm talking about building a self-aware network device, right? So I'm not, I think there's a lot of folks in the industry that are very, very smart, and they are amazing, amazing networkers, and they're amazing, amazing programmers. And they get up in front and they talk about all these great things that they've done, and they're like, look at this 10,000 line program that I wrote for my network device. And I, as a CLI jockey, look at that and I'm like, there is no way. And so what I'm trying to express here is, there is a way, just maybe not that good. So really what we're starting to see in the industry are open network devices. More vendors are becoming more and more open for some definition of open. Whether that's Cumulus being a Linux distro, whether that's Cisco and the Nexus 9000 opening up for Bash and Python, a lot of the stuff Arista is doing. But they're giving you access to Bash, to Python, to kind of lots of different tools that we as networkers have never had access to before, right? The training wheels are finally coming off. We're being treated like adults in the industry. And I think that's a great thing. Right? We're no longer locked into this little sandbox where we can no longer fall over. We're getting full control, right? We're getting our learner's permit taken away. We finally have an actual driver's license to go drive our car into a tree. And I think that creates endless potential, right? So now we have the ability to build software directly on our network devices. We've had Tickle in the past and we've had EEM in the past. I would rather have my fingernails ripped off than write Tickle scripts because it's awful. But now we can use languages that are not awful to write simple scripted programs, right? We can do this on box. But Open's also cool because we can do it with other software partners, right? We can push software vendors to start writing applications for us, for my network devices to do things, right? I'm no longer locked into just my network vendor being the only game in town to give me a software application for my network that I need, and that solves my problem. So the thing that's near and dear to my heart as a support person is, or as a person with a strong support background is, how can I make the box be aware of what's going on, right? How can I make that self-aware network device? What are some of the ideas that I now can dream up since I have full access to everything? So one of them is I can look at SFlow data on the box and have that box dynamically change routing, right? What if I dynamically change my routing metrics or build new traffic engineering tunnels or something like that based on SFlow data? And SFlow is not only a protocol, but it's also a company. The C something O of SFlow wrote an application on Cumulus Linux where he demoed this. Basically, the box sits and listens to SFlow traffic as it goes through that device and will reroute mice and elephants around based on that SFlow data. What about ACL accounting, right? How many of us are doing whitelist only ACLs and have absolutely no idea what any of them do, when the last time they were used. Before I joined in the routing team in the Cisco TAC, I was on the firewall group. And I would see boxes like 5580s, right? The formerly highest end Cisco firewall run out of memory due to access lists. And you look at it and there's hundreds of thousands of ACE entries. And nobody knows what they're doing. Nobody knows if they're in use. Nobody's willing to take them out. So what if we could actually create a way to not just say there's a hit counter? When was the last time it was hit, right? And I can start to think about things, can I implement a policy where any whitelist entry that isn't hit in the last 90 days gets pulled out automatically? And then you just call up the NOC and we'll put it back in if you really need it. But then I actually have the ability to control the resources intelligently on that platform. What about automated troubleshooting? I mean, how many people have had the problem that happens once a week, right? And you spend the next 6 months troubleshooting it because you need to be on box when it happens. Or you call the TAC, right? Whatever vendor TAC that is. And they're like, look, Mr. Customer, I'm sorry that this happened. I can't give you RCA. We weren't on it. And so you're like, okay, great. We'll get you on it, leave the case open. And then, it's like trying to launch a space shuttle. What if the box, beyond what EEM can do, beyond what Tickle can do, but what any programming language can do to look at that platform, what if I could rely on all those tools and write a crappy program, because again, not a programmer, what if I could write a crappy program to be the network operator on that device, to sit and monitor what I would be looking for as that network operator, and then start to run those commands and collect the data and actually try to troubleshoot what happened. And finally, dynamically adjust COP policies. So a lot of platforms are now shipping default COP policies, and that's great. And they open up BGP or they open up OSPF, and fantastic. However, that's still a vector for an attack. So if I open up BGP, I don't know who I'm opening it up for, right? That's great. I allow my peers to come in. But now if traffic from the other side of the internet, that is BGP traffic, comes in destined to my control plane, it's going to hit that same COP queue and starve out the legitimate traffic. What if I could create something that sits and monitors my configuration and dynamically adds those neighbors to my COP policies? So the only people allowed for BGP are my configured BGP peers. Because why on earth should I be allowing any other BGP traffic in? So I can do this manually, right? That's not rocket science, but I'm going to forget. It's a pain. It's another step in the process, and honestly, nobody's going to do it. So what if the box could automatically adjust its COP policy for me? So I'm going to show you a couple of these, hopefully, if the demo gods are nice to me today. So what we have, monitors on the other side. I have a lab. These are physical devices. So I've got two, leaf 1 and leaf 2. There's a bunch of other connections outside that don't matter. And these are going to be our two nodes that we're going to look at. So as I bring over the terminals to the other side. Oops. And this one. All right. So the S-Flow example that I mentioned, I'm not going to show because that's somebody else's code. So again, I wrote a couple of crappy programs, and I'm just going to hopefully demo them and show you some of these things that we can do. So the first thing I want to do is build a baseline for my ACLs, right? So as I'm talking about dynamically looking at when my last ACL hit was, well, I need to baseline this information. So I have an application. Can everybody see this, by the way? Is this large enough for the folks in the back? Thumbs up? No? All right. The mic? Stand over a little bit this way. The clip mic. Oh, that guy. All right. So hopefully that's big enough. All right. So the first thing I can do is baseline my ACL traffic. So all I'm doing here is calling my Python script, which is just going to look at my ACLs and build that baseline, right? So it's going to say, what are my current counters? What are my ACLs? What time is it right now? And then I can come back at some point later, aka the end of the demo, and look and say, what has or hasn't done anything since then? So I'm going to pause the ACL one and move on to the dynamic CoPP policy. Move this over a little bit. So what I can do is I can come back over to leaf one, and I'm going to run my dynamic CoPP policy program in the background. So it's just going to sit and listen and watch for configuration changes to update that CoPP policy. And then here, all I'm doing is watching. Oh, that looks terrible. I'm going to have to make this smaller, but the details don't matter all that much.
Now you sound like a sales engineer.
Oh. Oh. So what I can do is come in, because it doesn't matter. I mean, you can see some of these are from an earlier test in the hotel room, but I can come into that same device. So I'm on leaf one. So what we see on the left side over here, this is me just watching my CoPP configuration. So I'm not doing anything, I'm just going to see if anything changes. Over here, I can add a new BGP peer. This isn't an example of, this isn't a class in configuring Cumulus. But trust me that that's the config to add a BGP peer. And you notice the change over here. And so we added 200, 220. We can see that that's automatically added to the CoPP policy. So it's sitting there in the background monitoring my BGP configuration. As soon as that change is detected, it pushes the config for CoPP. It pushes all those ACLs into hardware. And I don't have to think about maintaining my CoPP policy as I add and remove neighbors in the future, right? So that's that one. And I'm going to kill this just because it will mess up my next demo. So that's dynamic CoPP. So the next thing we can do is take a look again at my ACL accounting. And let's look at a report right now. And I can see these are my current ACLs that haven't been touched in the data path. Right? There aren't a whole lot here, but we have 3 accept lines, right? One for HTTP, HTTPS, and ICMP traffic. And none of these ACLs have seen hits in the last 3 minutes. So what I'll do, I'm going to come over to the adjacent device. Oh, it's so big. Maybe, if I can find my window. All right. So I'm on the leaf 2, I'm on the adjacent device, and I'm just going to generate some traffic, right? So I generate some port 80 traffic, some web traffic. We're going to let that soak for a minute and come back to our reporting in a second. So we built the baseline. We've looked at the report once, and we saw that we don't have hits on these ACLs. Maybe we want to remove them, or maybe we just want to know we can generate some traffic and come back and take a look in a minute. So in the meantime, while that's soaking, let's take a look at the idea of dynamically troubleshooting a BGP neighbor failure. All right, so I've got a pair of BGP neighbors. We've probably all had this happen. In the middle of the night, my remote peer, who's a box I don't even control or own, flaps. All of a sudden, you get a ticket from the NOC, and you're expected to give RCA at why 3 in the morning you had a 5-minute BGP outage. Good luck. So, if I come back over here on leave 2, I was trying to figure out earlier if the wireless in here is better or worse than wireless on Amtrak at this point. I was going to say I think Amtrak's winning right now.
Somebody's still on the track.
Yeah, well, I wasn't going to go there. Oh, I didn't even think about that. Oh. See, that's how you know that I'm not really a sales engineer, because I wasn't smart enough to take that slide out. So again, I'm running my neighbor capture. I'm running it in debug mode so I can see, so we can actually see that it's doing something, right? So I'm sitting here and I'm monitoring my peers. Okay, my neighbor is alive. I'm just going to hang out. So I'm going to, in another window, I'm just going to create an access list policy that blocks outbound traffic from the peer. So the peer is going to stop sending BGP keep alives, but everything else is still going to work. The lag is killer. You like go down 2 lines and then you're like, oh no, stop. I went too far. So this should hopefully die. All right, so we see that it started troubleshooting the neighbor. It's building a log file. It's collecting some data, some predefined things, CPU, memory, TCP sockets. It's going to ping the box. It's also going to run TCP dump. Hopefully TCP dump works. I've found that there's some problem where TCP dump truncates the capture and the capture gets corrupted here. But again, bad programmer. So my neighbor died. Why, right? Again, this is my middle of the night BGP failure. So I can look at the log, and so first off, I collected CPU data, right? Where you've got our highest process is at 20%, so it doesn't look like it was a CPU failure. Below that, so that's all CPU information. Below that, we can look at some memory. Maybe we had an out-of-memory problem that caused the peer to fail. Looks like memory looks clean here. Let's look at the TCP sockets. Looking at the TCP socket, it's interesting, we actually have a bunch of packets in the TCP queue. You know, that's a big red flag to me. Maybe this is related to what happened. right? I look at poorly formatted due to size, but I can look at, show interface style counters. Do I have drops? Do I have overruns? Am I taking hits on that interface? Was that the problem? It looks like my interfaces were clean, so that wasn't the issue here either. And I can even ping the device. So now I see, wait a second, not only do I have packets stuck in the TCP queue, but I can still ping the device. This is clearly a layer 4 through 7 problem, right? Something happened either at TCP, somebody, the firewall that everybody said isn't there is actually there, or the BGP process crashed or the routing process crashed or whatever, right? So this is data that I collected dynamically, so I actually have a chance, right? Maybe it's not going to give me everything I need, but I've never actually had a chance of solving this problem before. And so finally, and then again, within here, we also have the capture, right? And I can look at that capture and I can make it as narrow or wide as I want. So maybe I want to throw it wide open because I saw a flood of traffic related to a spanning tree loop, right? Maybe that's what happened. So if I'm only capturing on BGP, I'll see the hellos, but that wasn't really the problem. The problem was this flood of broadcast traffic, right? Maybe that's what I see in my capture around the time of the failure is one source MAC over and over and over and over again. Maybe that's what happened, right? Again, it's all about, can I get an RCA or can I get closer to an RCA than I've ever been able to get before? And then finally, we can come back to our ACL accounting, right? So we sent that traffic, we let it soak, we built that baseline. And we can see that one of our 3 accept lines, right? Earlier we generated some web traffic. Well, that web traffic ACL had hits. So it's been used within whatever threshold we've defined, which in our case was, I think, 1 minute or 3 minutes. But I can see the last time I saw HTTPS traffic was 11 minutes ago. The last time I saw ICMP was 11 minutes ago. Maybe this is 30 days, right? So I say, look, the last time I saw whatever these 2 endpoints are, the last time they sent traffic was 30 days ago. I'm pulling that ACL out and preserving my limited ACL space, right? Because especially as we start to move towards more and more hardware-based platforms, you have very, very limited ACL space, right? These are resources. I mean, I would go even as far as start charging your end users, right? Do chargebacks. If you want a CPU of compute, that's fine. If you want whitelisted ACLs, we can do that too. Have your department pony up. So that's my little demo. It did not crash and burn, thankfully. My very uncouth slide. So really what I'm trying to say here, and what I'm trying to get across to everybody in this room, is it's okay to write bad code, right? I can say this because I'm not a developer. I'm not writing network operating systems. But as a network operator, it can be okay to write bad code, right? Invent, create, play, get on the box, start writing scripts. It doesn't have to be perfect. It doesn't have to be multi-threaded. It doesn't have to use the most optimal data structure. Who cares? If it does what you need it to do, I think it's fine. Give back, right? Put everything on GitHub. All my examples are on GitHub, GitHub/Plumbus, P, my last name, Plumbus. Put it on GitHub, right? Not because somebody's going to fork your project and it's going to become this amazing, widely used open source thing. It's because there's a whole lot of people out there, just like me and just like some of you, who essentially just hit the keyboard until a program pops out. And so a lot of that is copying and pasting other examples, right? I want to see, hey, I have no idea, like, how do I even look at the BGP peers to dynamically troubleshoot them? Wait, how did Pete do it? Oh, well, that's stupid, but at least I know how he did it, so I can do it my own way, right? There's a lot of value in that giving back. Again, not because we're trying to create the next Apache Foundation thing, but just because, we do hard work, right? And it's the same reason why people write blogs and the same reason why people talk on Twitter about technology. Same reason why we're here is because that sharing, that community is so valuable. And push your vendors. I mean, really beat them up. And that includes me, that includes Cisco, that includes Arista, whoever it is, right? Get them to be more open, right? That's going to give you choice, it's going to give you flexibility, it's going to give you power, right? Take those training wheels off, get treated like an adult for the first time ever in our industry, and do whatever you want. Because the power that that gives you as an operator to do your own stuff is amazing, and the power that that gives third-party software vendors to come in and solve your problems for you, right? So maybe you write bad code, but you're willing to pay somebody money to write good code. Now they can do that. We've never really had the ability to give money to somebody to write good code to solve our problems, and now we can do it. That's all I got. Any questions? Thank you. All right. Oh, we got one.
So in this hypothetical example, what was the cause of the BGP flag?
So on the adjacent peer, I put an access list that blocked all outbound BGP traffic. So it was the same as if there was a BGP keep alive failure. A lot of the other ways that I tried to cause it to fail created a TCP fin or TCP reset, so it gracefully tore down the neighbor. I wanted something more mysterious, right? Like I'm sorry? The packet trace would have saw the fin, but it's less interesting. And so it's really looking at, if I have like a switch in the middle and there's that link break in the middle, I'm never going to get a graceful teardown. It's going to be a keep alive failure. So that's really what I was looking at in that case.
What approaches have you thought of for scaling this? I mean, you showed us 2 switches here. What about if you've got, hundreds of BGP pairs across, tens of routers? Are you guys looking more towards centralizing your alerting and centralizing your file configuration? Or are you trying to think about running all these processes on all these routers all the time? Like, especially your troubleshooting one that would detect a down peer, and I find that interesting, but how does it scale?
I mean, the answer is that it's like anything else, right? If you're talking about scale, then bad code doesn't work, right? If you're running the route server in IX, please, for the love of God, do not use my code. Right? That's a terrible idea. But I mean, that's where you can come in and you can give somebody money to write an application that is multi-threaded that actually works based on this concept, and you would run it on every box. We have some internal proof of concept stuff related on Redis databases where we can dynamically do it within the network, right? So every box has its own little database of information, and then we can use whatever communication channel between the devices. So I'm essentially treating my switch or my router as more of a server. So the short answer is your scale is limited on your network device like it is on any server, compute and memory. The longer answer is if it's really something you're strongly interested in, that open platform, whether it's from Cumulus, whether it's from Arista, whether it's from Cisco, gives you the ability to hire an actual software developer to write code that will scale.
Not just hire someone, but also sometimes, in rare instances, when you're on GitHub, you post something that's out there, and someone, let's say in Israel at 4 a.m., will send you a pull. It just says, oh, by the way, you had an error. I did write 5 more lines. It solves this, and this issue, and I'm using it. Enjoy. And now everybody has it.
Yeah, exactly. So for those of you that might not have heard, right, the comment is, what's great about putting your code on GitHub is even if it's not great, you might be pleasantly surprised at the 4 a.m. Git pull request saying, hey, I saw your code. It solved my problem. I'm better at this than you. I fixed all these problems in your code. By the way, let me give it back to you. That's amazing. I would love it if somebody fixed my problems for me, right? And that's, again, kind of, we're getting one step closer to me fully outsourcing my job and living on a beach with drinks with umbrellas in it. We're not there yet, unfortunately. Wait a minute.
Just a comment. This is great in that it provides tool access to the hardware. I think it's important that people consider that this can tie back into whatever your central monitoring and analysis systems are.
Yeah.
So when you get to the point of really using something like this across your enterprise, tie it back. Use the opportunities that your monitoring vendor or whatever package you're using at the core to track your events, to track your logging. Tie it all together. Because when you start to take information like this and cross it with application information that might be logged in the same system, and cross it with business event information that might be logged in a similar system, now you're getting to the point where you can see where business has caused software to cause network problems.
Yeah.
tie it up to the whole stack.
And then, I mean, that touches on like a whole rant that I'm not going to go into about how we have Stockholm Syndrome as network operators around SNMP, and we think that it's the best way to solve problems, but it's awful. It's absolutely awful, right? And so now we have the ability to collect the same data that SNMP collects for us and put it back into our central monitoring in whatever way we want to, right? And being able to do that, again, we've never been able to do that centralized reporting on arbitrary information, right? On the number of users logged into the box. How would I collect that before? I don't know. I would probably hit my head against the screen until I found the right OID, which I wouldn't find, and then I would open a support case, and they wouldn't find it either, and then I would give up and just decide that information is not very important for me to collect. And so now I have a better way. I know exactly how I would find that information on the box, and now I have a way to present that back to central monitoring and management and event correlation. Anything else? All right, go write bad code.